Boom, boom, All right, good people. Well, thank y'all so much for pulling up. Another fantastic day in the web, right? If I do say so myself, right? Well, last time we linked up, we started the process of talking about how do we connect the React application to an Express server, right? And you know, live coding, things get hairy all the time, but we managed to make it happen that we were able to actually pass this little bit of data that we built on a server into a running React application. So first thing I want to do is just recap the process and just show off what we're talking about here and make sure that we kind of understand the core concepts. And to do that, we'll review a couple pieces of code, one on the server side, one on the client side, talk about how they got connected, and do a couple more examples so that you understand how you would write your server side routes in order to allow for other client side applications to connect to it. So if that sounds good and you're ready to rock with me, just give me a thumbs up, show me some love. Y'all already know the vibes. I'm here for y'all, and I appreciate y'all's time and attention. Thank you, thank you. You're far too kind. I appreciate y'all. Wonderful, wonderful, wonderful. All right, boom. So right now, y'all can already see if you take a look at my browser URL, I'm hosting a server right now on localhost. So that means a local development server is running on port 3000. And there's a particular route that I built called slash favelink slash data that is returning what looks like an array of JavaScript objects, right? This is being returned in a format, a data format called JSON. And JSON is just a popular format for us to share data across HTTP requests. It's very popular. It's a very popular data format. But what makes it really special for us in the full stack context is because it's JavaScript object notation, it becomes very easy to pass this type of information into JavaScript applications. And we'll get back to just how great that is in a few. But like I said before, what I want to do is just show, now that we've seen a little bit of what we built on the server side, let's take a look about what we built on the client side. So just give me a quick second to launch that client side application, and then I'll pull it open in the browser. So just do a quick npm run dev on this. And all right, so our client is running on localhost 5173 because we built it using React and Vite. For those of y'all who are familiar, right, Vite is just a React building CLI that we can use to just launch our project. It by default uses port 5173 in order to launch our projects. So right now, I just went ahead and ran the React project we have on localhost 5173. We'll see the code in a quick second, but I just wanted to show you, just to recap what it was doing. That code that we built was essentially a small application to store our favorite links on the web, right? The point of the application was to allow for us to have a list of links, and then we're able to add to that list of links. If I have another particular site that I wanted to add, I would be able to add that to this particular list. So what we did that is special about this is, as you can see, when we first launched the application, we actually start with a couple of links, right? And if you looked real quick, closely, very quickly at the beginning, you can see that there was kind of a little bit of a lag between there being links there and there not being links there. Give me a thumbs up if you saw that, right? I'll refresh it one more time, right? There's like a little bit of a lag where for a quick, brief second, there's no links, right? And then all of a sudden, one more time, all of a sudden there's links, right? Well, what's going on here is that we're actually performing a web HTTP request to get these links from the server. So for a brief second, our application loads, and then we're saying, hey, go out, make the request to get this information from the server, and then pull it into our application, which is why after a quick couple seconds, our app loads finally with a little bit of starter data. And then we're able to continue to use the app as we normally would have in order to add links themselves. Now, if we go back to what I was talking about earlier on the server side, right? If you look very closely at this JSON, I'll just zoom in just a little bit so it's a little easier to read. You can see like there's two objects in this JSON data, right? The objects, each object has a key for a name, and that is holding the name of the website, and a URL, which is holding a string for the URL of the website. And clearly, when we go back to our running client-side application, you can see that those are the same names and URLs that are featured here. So essentially what we were able to accomplish last time was from this data that's on our server, we were able to send this data directly into our running React application, right? And that was the big thing that we got accomplished the last time we came together. So we're gonna just recap the code and just talk about how it's working and what you need to do in order to get it to work on your side. And from there, work on a couple small examples in order to better illustrate the idea in more practical ways for y'all. So let's switch gears and take a look first at our server-side code and what's going on there. So y'all should be able to see my VS Code window now. And in that window, we have just a server-side project in here. The most important file for us in the server side is going to be this index.js file where we create our Express server. So we built this server using Express. Express is a JavaScript package for allowing us to launch server applications in Node. Basically, Express does a lot of really complicated things for us that allow for us to build a server using JavaScript. If it's one of the more common server-side frameworks in JavaScript, and definitely one worth knowing if you're gonna be in the full stack space. So in order to create an Express application, there's a couple steps that you have to do. So I'll highlight those steps first, then we'll come back and talk about some of the other code that is here that we won't we'll gloss over a little bit. So the first step when you're creating just a regular Express server is you need to import the Express package. To do that, you have to first install this package using your package terminal inside of your folder. So in a terminal window, one of the things that we had to do was start a new Node project, and creating a Node project was what gave us our package.json file. And the package.json file is essentially a file that just dictates what are the dependencies and packages that we wanted to use within this project, as well as like what is our main JavaScript file that is associated with this particular project. In order for our index.js to be able to pull in the Express package, we had to install it. And so first we needed that package.json to be able to run some commands. The second thing is we are then able to do commands like npm install express, which is the command we use in order to create this node modules directory that included all of the different packages and dependencies that we needed, including Express, but also all of the packages and dependencies Express needs in order to work. So that was the step one behind the scenes that maybe kind of gets glossed over a little bit when we just look at the final code. But it's important to know that that's what we did first. After we did that, we were able to import Express like we're doing here on line 2. When we're working on the server side, imports and exports are handled a little bit differently than on the client side. I'll point out an example of that when we get over to the client side code. But on the server side code, when you're working on a node project on the server side, you're going to use the const require syntax in order to import packages or files into your server side code base. So what we see here on line 2 is us importing Express into our project. That's the first important step for building out our server. Servers themselves are very specifically doing 2 things: listening for client requests coming in on a specific port and responding with data through a responding with data back to the client. So to do these 2 things, what we have to do with Express is we first create a new Express application. So on line 10, what you see is us creating that new Express application. It's simply just a variable that is going to represent our Express application. Express itself is a runnable, executable function. So we can use that function in order to make this app variable. We just defined a version of an Express, a new version of an Express application. So all Express apps, like I said, are going to be listening for client requests and responding with data, much like any other server-side library will do as well. So in order for us to listen to client requests, we need to allow for traffic to be listened to on a particular port of our hardware machine, right? So our computer is capable of running different servers on different ports of its own machinery. So we have to be specific in saying, hey, this server is running on this particular port of a machine. Some ports are open, some ports are closed due to specific processes you might be running on your machines. Typically, when you launch a server in a enterprise context, it's way different than like your personal computer, right? These are servers that are sitting inside of rooms and big data centers somewhere, right? And those servers don't typically have any visual component attached to them. They're just the hardware running, right? And because of that, you might have access to way more ports running than you might think are available. And so it's important just to know that when we're defining a server port for our client requests to be trafficked upon, we are typically going to try to use ports that are uncommon enough that they won't be taken by other processes on our machine, but common enough that we can say, hey, just use this port number because we know nothing's there, right? And so in the web dev context, you actually see port 3000 is used in a lot of tutorials and stuff, or a lot of starter code. Sometimes you see 8000 is used. Sometimes people say port 8080, right? So it really depends, but safe bet 3000, unless you're running some other server using 3000, and you would know if you're using a server using 3000 because you probably launched it yourself. 3000 otherwise is a good bet. And then there's some cool code you can write as well to make sure that, hey, if you try to start something on a port that was already being used, hey, just increment the value by 1 or something, right? So that's also a pretty cool challenge if you're open to thinking about how to refine this to be a little bit more dynamic, also in saying which port is going to be the port to be used. Well, let's keep going, because that's a long-winded way to just saying, hey, you have to define a port for your particular application. What we have here is us creating middleware. I'm going to skip this for now, and we're going to come back to it in a little bit because this part isn't actually a requirement. It's just something that you might do depending on what your server is going to be returning later. So we'll skip this part for now and come back to it. So all we've done so far is installed Express, created a new app, created the port information for that app, and then we're able to start creating routes, right? And as a recap, routes are essentially small functions that take care of defining what are the path that a client can take, what methods, HTTP methods, can a client use in order to reach out to our server and get some data coming back. So in this particular route, you can see that this was a HTTP GET route. So if a client is looking to get some information, they will use the GET method in HTTP. And every route, no matter what route it is, whether it's this one on line 25, this one on line 31, etc. I don't think I have any other ones right now. All of these routes do the same thing, which is define what HTTP method is this particular route listening for. Define a path that a client would be trying to access, and then define a function or a handler for what should I do when that client finally makes the request to my particular, what should I do when my client makes a particular request to that particular path, right? So this is the syntax for all routes, no matter what. They're gonna look the same in terms of what's going on here. So after getting your app started with Express, defining your port, go ahead and just launch some routes, and those routes then correspond directly to what you are able to then run on your server when it finally starts listening for traffic, which is the last step in Express, is to start your servers listening to a particular port. You have the option to define a little callback function for when the port, when the app finally starts up. So it's common that we'll keep a console log message in here to just say, hey, once you start listening, just let us know. So we're good to go. And that, my friends, is how we would launch an Express application. So once you've created that Express application with those particular areas, so let's say creating the routes, right, making that sure the app's listening, defining the port, creating the Express application, and importing Express. So 5 steps, right? Step 1 is importing. Step 2 is launching the application. Step 3, creating the port that you want to use. Step 4 would be like creating whatever routes you want your client to be able to reach. And then step 5 would be listening finally to the app, right? Those are the 5 steps you need to launch an Express application, period. So if that part makes sense to you, just give me a quick thumbs up. Just want to do a pause for knowledge sake and checking for understanding, making sure that at least that part makes sense to folks in the process of launching your own servers. All right, cool. That's great to see. And again, if you have a question, feel free to drop it in the chat. No problem. No problem. Bet. So now that we've done those 5 steps, right? And as I wait to make sure if anybody drops a question, please go ahead. Once you've done those 5 steps, then you're able to go ahead and in your server, call those routes and see what happens when those routes are called, right? So for instance, this route, localhost 3000/favelink/data, remember, it was the route that I told you we built out to share some data. We'll walk through the code for that a little bit more specifically in a second. But the idea is that this route is a active route on my server, right? You see localhost :3000 is the port that we defined in the Express server, and /favelink/data is the particular path that I had in my routes. So one more time, to just nail that point home, right? All you need to start an Express server is to import Express in your project. That's step 1, right? So I even labeled this so it's even better. Step 1, right? Import Express into your project, right? Step 2 is creating a new Express application, right? Did I do that consistently? No. I went colon to to parentheses. That's wild. That's unhinged. That's giving serial killer. I gotta chill. Step 2 is create a new Express application, right? Step 3 is to define the server port that you're using, right? Like what port are you going to use? Are you going to receive traffic on from your clients? Step 4 is creating your routes, right? So I'll just put step 4, create your routes, right? So these are examples of the routes, right? And then step 5 is start the app listening to traffic on a particular port, right? So these would be the steps. And everything else that we didn't just touch on is then extra stuff, right? So some of the stuff we skipped over are like things like this, right? This stuff with the middleware. We'll talk about that again in a second. And then this importing cores, which is something we did last time we connected. So those are the steps for those of y'all who are curious about that one more time. But like I said, right, if we take a look at these routes, right, on step 4, you can see I have 2 routes right now that are listening for clients making a GET request to these particular paths, right? So if a client makes a GET request to /favelink/data, this is the particular function that will be called when they do, right? So taking a quick look at that code real quick, right? What this function is doing, if this was just an isolated function in JavaScript, right? It's not doing anything too crazy, right? It's just defining a variable called data that has an array of those objects that I just talked about, right? Of the name and URL, et cetera, with some strings in there. And it's sending that data down to the client as JSON, right? Every route, when you're handling the traffic from the route request, you have the option to look into the request object that got sent into your handler in order to parse information about the request from that request object. But you also have a set of built-in functions in the response object that you can use to send data to a client, or send JSON to a client, or send a status code to a client, send a file, all those types of things. So all routes have this kind of internal logic to them, right? We listen for the traffic on the path, then we respond in some capacity using a function. Because this is a function in JavaScript, we could do all types of stuff. We could define a variable. We could import some other stuff, right? We can run any JavaScript code that you can think of. You can put in this function until you're ready to say, hey, I'm now going to send this data back to the client, right? So you have some time prior to sending it to do some stuff. And in this case, the stuff we decided to do was create some data to send. And hopefully that makes sense. So just give me a quick thumbs up on that part, right? This is just a super simple function. We created some data and then we sent the data back. That was all that this function was meant to do. Where it gets complicated is not in any of this part, right? We were able to do all of this part. If you go back to the last video, right, you'll see we were able to do all of that part pretty easy. That was nothing. That was cake. Where it gets complicated is in the process of connecting a client to this active server. Now that we have the server running, all of that, right? That's great. That is part A of the series of parts we need in order to get this to work. So let's switch gears and talk about part B, right? Which is the client side. So let me just pull up this client side code real quick. Sorry, zooms in the way. All right. And I will reshare us to a different VS Code window, right? In this VS Code window, you can see still I have up the terminal that I launched with Vite. And remember, Vite is just a little command line interface for Vite provides a package for building React code and other JavaScript project code. We've been using it to like launch our quick React projects, but Vite also has its own little local development server built into the library, so you can very quickly launch a development server. But given what we know now, right, we know what it takes to launch something at localhost :5173, right? That's just a little server running in the background. So what we'll talk about toward the end of today is how does Vite allow for us to launch this little local server that shows us our React code? And we'll emulate that a little bit ourselves. But first, let's just talk about what we needed to do in order to get to connect to the server and to make requests from the client side, right? Because I'm sure as of right now, that part is probably still a little confusing, and for a good reason, because there's a lot of things that come up in the process when you're trying to reach out to a server from the client. So first off, let's just talk about this whole client server thing, right? I'm sure somebody was like, yo, bro, you keep saying client and server, and that's confusing. If that was you, just give me a thumbs up. I get it. You know what I'm saying? You're like, you keep saying client, you keep saying server, but what is that? It's all good, right? So on the server side, right, the server is just any kind of process or computer process that's listening for requests and responding to requests, right? A client would be any other process or computer that is making requests, right? And sending requests somewhere to get information or deal with information somewhere else. In our case, the Favelinks project is pretty straightforward. Again, I won't belabor the point and talk too deep about the code. It's a very simple React project. We have a couple components. The app component returns our link container. The link container is a component that renders a form that has a couple inputs, right? And the form sends data back up to the link container, which then sends that data using state down to our table. The table pulls that information back as props, and uses it to show all of our data, right? That's basically how this application works. So while the form is important for the collection of the data, changing the state and getting that data eventually sent to the link container, and the table is really important in visualizing the data that it's getting from the link container in the as props, right? That just goes to show that in this project, our link container is actually our main project component that is dealing with a lot of different pieces. Because the link container itself is responsible for rendering our table, rendering our form, and passing data down to the table, but also receiving data from the form through a couple of different functions like this one here. So that's what's going on there in the code. But what we added, right? What we added was, if you see at the starting point, we start our application with an empty array of links. We don't have any links. That's actually why when I showed you earlier, we were having a little lag, because the app actually loads with an empty array. Then what we worked on last time was fetching data from the server that was sending us, that had the data established, right? We already just saw in the server side, we built a route that was returning a JSON object of 2 fave links, right? Well, what we wanted to do was grab that data from the server in order to pull it into our application on the client side, which is our React application side, right? To do that, we had to make use of a JavaScript library that it's not a library, excuse me, but a JavaScript function that is built into JavaScript that we can use to make requests to other servers. And that particular function is the fetch function. When you read about fetch, you'll learn that there's a lot of different things that you can do with it, particularly with relationship to how you can use fetch in order to make requests to make different types of requests to servers. But in its simplest form, what you can use fetch to do is perform requests to those servers that you have, right? It can either be a local server like the one we worked on, or it could be an external server that has that's giving you the permission to pull that data, right? So we'll get back to what that means in a second, but I just want to take a quick second to talk about the fetch function one more time. And the fetch function is a pretty simple function, but what it does is very complex, and that can be a point of confusion for a lot of first-time programmers in JavaScript, because you're going to be introduced to some concepts that are fairly difficult to both conceptualize and explain until you've actually have built a couple apps that are doing network requests. So here we go. Trying to explain my best. try to explain it, right? I'll say, alhamdulillah, let's make sure we can do it. So, all right. So when you're making a networking request, right? And a network request is basically one computer making a request to another computer, which is basically what we talked about, is our client reaching out to our server. In order for that communication to take place, we're performing what's called a network request. Network requests send back data, they definitely do, but the process time of sending back that data is kind of undeterminable to a degree, because you're running 2 separate processes, right? So on one side, on our side, on our application, hey, we just say, hey, I want to just get some data, send me some data, right? But if you think about it, it takes some time for the computer to fully reach out to another server, take some time for that other server to go ahead, get the information it needs, and finally return that information back to us, right? We can all agree that that probably is going to take some time. That's kind of hard for just one client to just say, hey, I know exactly when you're going to send me that data. We really don't, right? If that makes sense, you give me a thumbs up, right? Like, because the server has its own stuff to do in terms of listening to the request, getting the request back, running the function finally, right? Like, there's a lot of different things the server is going to have to do before it's finally ready to give us back some data. So we don't really know when that data is going to come back. But on the client side, we don't really care. It's like we're like think about it like think about it like the client and server, right? And you know, you the client and you go to McDonald's and now they the server, right? And you at McDonald's and you like, hey G, I just want some chicken McNuggets. Like, I don't care how long it takes you, but I do care if it starts taking too long. You know what I'm saying? But I can't go in there and say it's gonna take me approximately 15.43 seconds to get my chicken McNuggets. Like, nah, you know what I'm saying? You don't actually know, right? You're relying on the server to get that information and get that back to you. That's the same thing going on with these processes. If that metaphor made sense, give me a thumbs up. I think I like that. I was like, that was kind of raw. You know what I'm saying? I just slid that little McDonald's on in there. You know what I'm saying? That's kind of cool. You know what I'm saying? That's kind of lit. Anyway, pause aside, right? So the same process is happening when we're having these two computers reach out to each other, right? So what JavaScript does in order to make it so that our code can continue to work, despite the fact that we're waiting on something from this network request, is it uses a data type that is a fairly sophisticated data type that's called a promise in order to fulfill the needs for our code to function. Promises are essentially JavaScript objects, right? So promises themselves, you know, like promises themselves are essentially JavaScript objects that basically, let's see, like basically the way that a promise works is we use the promise in order to substitute the data that would come back immediately from the server. So we don't necessarily get that data immediately coming back. So what we do is we return what we call a promise. And the promise itself basically has three states to it. The first state is kind of like, hey, you know, undetermined, like we're still kind of resolving something, like we're still in the process, right? That's stage one. Stage two would be resolved, right? Like the data came back, everything finally finished, it was resolved. And then an error would be the third stage, right? So promises could either be unfulfilled, resolved, or errored out, right? There was an error. Because of that, right, we can get back the promise. And how a promise works is we get back that information from the server. Our code can continue going. And then later, the promise itself will change based on when the server finally fulfills its job, it'll get us back that data. So when the McDonald's team folks figure out how to get your order together, they finally come back to the window and say, hey, here's your order, right? So you could think of the promise almost like a little receipt in a way, right? Like you got the receipt that says, hey, you know, we're good, we got your thing, keep going, we're gonna keep going, right? And either they're gonna come back and give you your stuff and your order and everything's good, or they're gonna come back and be like, yo, actually the deep fryer just broke, so we can't get you those chicken McNuggets. You know what I'm saying? Like something just broke. We don't know what to tell you. You know what I'm saying? Like, so you can think of promises kind of like that, right? A promise is either going to be fulfilled or there's going to be an error, right? And if it's fulfilled, you get back what you expected. And if it's not, you get back an error that says, hey, you know, there was an error. But you get back something in the interim while the promise is being worked on, right? That's how the networking space works. So that's very important to know, only because a fetch request is one of the types of functions that lets you perform network requests. So how fetch works is it sends back promises. Now, there are two ways of dealing with promises in JavaScript. One way is using a more old syntax where for every promise that is being returned from a particular function, if you want to wait until you've gotten back the promise and it's either been fulfilled or it's been errored, or you know, an error happened. There were two ways. The old way was we had to use this kind of chaining syntax that looks kind of awkward. Where, for instance, if I were to just rewrite this, and we'll get back to the second way in a quick second, right? It would look something like, hey, you know, perform a fetch request to the same URL, right, to our little URL that we have here. And I would say dot then, right? Then once this fetch request resolves with a promise, then I'm able to run a separate function, right? That will have the result of the promise as, you know, as accessible data in the function. It's like a callback function that gets called once the promise resolves. And here is where I can say, hey, you know, I got this result from this fetch request finally. Now I want to call result.json on it to get my data, right? And the problem is result.json in this case, it's not necessarily a big problem, but result.json is also also resolves with a promise, right? So because this resolves in a promise, then I have to also chain another dot then on it, right? To say, oh, well, you know, when this data comes back, right? I can't even do like let data like this. It's kind of like call this other result.json, and then I get back the data. And then from here, then I could, you know, console.log my data or whatever, right? So this is like what the chaining syntax looked like. It was just a lot of dot thens, and then you also had a dot catch in order to catch if the promise was rejected, right? And so here we would be able to create a function for, hey, you know, if I got an error, right, or something came back, it was something bad happened, right, I could console log that error. So this was the old way of how we used to do a fetch request in JavaScript. It was like a lot of dot thens based on each promise that was being called, but based on each function. And you would know because each function would let you know, hey, I'm going to return a promise, or hey, you know, result.json, hey, I'm going to return a promise, right? Okay, well, for each promise, we need to do another chain thing and catch any errors, right? But as you can see, this syntax is kind of hard to read. It's not the most easy to understand, and it could just be low-key overwhelming for people who don't want to see all that, right? So that was the old way. The newer way of using JavaScript, given some of the changes in the language and syntax, is for us to use the async await syntax, which in my opinion makes it a way easier process to do these networking requests, right? Essentially what the async await syntax lets us do is we can mark any function that we're going to run that is going to perform any networking requests as an async function. So here I have a function called fetch data, and it's an async function. Because I marked it as an async function like so, all I have to do is add this little keyword in front of my function, right? Because this is marked as an async function, I can use the await syntax to basically say, hey, wait until this promise finishes and save the result into some data, right? So it's doing the same thing as these chained methods, but instead of having a chain and keep looking at functions, pulling those information in, you can basically just use the await syntax to say, hey, wait till this promise resolves and save it, whatever that resolved thing is, to this variable, right? And you can see we did it twice because, again, response.json, the .json function from the also returns a promise. And what that does is one, just makes our code way more readable, right? Instantly makes our code way more readable, in my opinion. But you might still be wondering, well, okay, well, that makes sense. You talked about the promises. I get that. Like, I get the promises are going to, you know, take some time and they're going to resolve, or they might have an error. But what does that have to do with what fetch is doing? That's what I'm confused about, right? That's what I don't understand, right? Don't worry, fam. I got you. The fetch request itself is basically just going to make that a HTTP request to our server. Think about it like, if I want a client application to talk to a server, I'm going to use a function like fetch to reach out to the server. That's how you do it in JavaScript. There are other packages you can do that do it in other ways. But the difference between fetch and those other packages like Axios or anything else is that you don't have to install fetch. It's already in JavaScript for you to use, right? But some of those other packages that some developers use for network requests, you'd have to install into your project. So because of that, fetch is just pretty popularly used because it's just out of the box. So to answer your question, fetch is specifically the function you'd use to call any of the routes that you have on a server or any server that is running routes. One thing that is important to note here is the way fetch works is we have to use a full URL, right? And localhost is since we've been working with it, localhost is just kind of localhost, right? But you can access localhost at in your local HTTP using the HTTP using HTTP protocol, you can reach out to your local host server like so. So this is how I turned the local host into a full URL, right? HTTP:// and then I can do the path of whatever route on the server I want, right? And remember, our server was running on port 3000. That's why we have the port 3000. Then everything after the port 3000 is the routes on the server we wanted to listen to, right? So remember, we had /favlink/data. That's why this route is this route. And remember, the server is waiting for clients like this to say, hey, I want information from this route, right? What we're seeing in this very basic example of the fetch request is us making a GET request using fetch, right? If you want to do other requests, you have to add a couple other lines of, you got to add some other stuff into the fetch request. We'll see that in a second. But when you're making a very simple GET request, it's really actually just one line to make that GET request, just like this, right? Once you make the request, right? And here's where we'll break down kind of just this bit of code that we see here. Once you make this GET request using the fetch, right? It's going to resolve the promise that comes back from fetch. What fetch does is it's going to basically come back with whatever the response is from the server. That's why I call this variable response, because if you remember on the server, the last thing the server does is send something, responds with something. So I called response basically whatever the server came back with after that first promise resolved, right? The thing is that what the server will come back with a response is going to be this very interesting object that has a lot of different like information about the response, but it's not going to show the actual data specifically. And I can show you that real quick by just adding a console log for that response into the code here. And I'm sorry, it keeps popping up like this. But if I add a console log for the response in here, right? My bad, y'all. My computer is bugging, so it says it's not gonna let me save it real quick. If I added a console log to the response right here, take my word for it, what we would see is just kind of a bunch of random stuff that says that the response happened, but it's not gonna be comprehensible. It's just gonna be information about the response itself. Nothing with the data that we had coming back from the server. In order to get that data back, I have to parse that response and get to the data that's inside of that response. To do that, I have to basically say, hey, I want the JSON that this response might be returning. And I know that that response is in JSON because I work with the server. I wrote the server. I know what's going on there. If I was reaching out to an external server, I might not know, right? So that's important for when we're working with external servers, external APIs. That's why all APIs and external servers give you documentation on how do you make a server request to that particular route, and what kind of data is going to come back. So you can preemptively create your client-side code to say, hey, you know, I want responses data, or I want the response text, or I want whatever the response, however the response was sent, I want that information, right? So our two steps to go back to the simple, what do we have to do, right? The simple, what do we have to do is if I want my React app to connect and communicate to my server, I have to use a fetch request to get the data. And I can use a fetch request to get the data, to post data, etc. But for now, just because all I wanted to do was get the data, here's how I can do that with a fetch request, right? Once I get that data, because the data that I particularly sent was in JSON, I need to parse the data as JSON in order to make use of it. Once I did that, which was just calling this response.json, I was able to set my favlinks, right, which is just a state function here in the state hook, to say, hey, set the first array to be that JSON that came back because it was an array of data, right? And that is how we were able to pull those extra fave links from the server into our client side application. Long-winded, I know, because I really do need y'all to understand that async await is lit, and it's a great way to write these network requests. But it's important to understand where it came from, and how that relates to this concept of promises in JavaScript. And so that's the part that gets a little bit tedious to talk about. Now, the last thing you need to know is, funny enough, right? It would be great if it was just this simple and all you had to do was just say, fetch the data, and you got the data miraculously back, right? But security systems don't like that. You don't want somebody to just pull up to your server, grab data without even telling you, like, who are you? What you doing here? You know what I'm saying? Should I even give you this data, right? So because of the way that security works on the web, it actually isn't allowed by default for other clients to reach out and get data from a server, right? Like, what that creates is called cross-origin resource sharing. Now, what you can do is, if a machine is on the same origin, so like you're still running from the same server, right? You can get access to that information because you're from the same, you're running on the same server. Because these are two different servers running, right? It's kind of a security precaution to just let some external server grab data from the server that we have running, right? So what happens is, by default, when you're performing requests like this on the client side, you're going to run into issues with getting the data back from the server that are related to a topic called CORS, right? Again, my John is tweaking a little bit. Let me see if I can fix it. 1 second. I don't think I will be able to, but you know what I'm saying? It's never too late to try. Never too late to try. Let's see. Dang, what's the best way to do this? Well, man, I want to trigger the error, but to trigger the error is going to require a couple things. But y'all remember last time we were getting some errors in the console, the JavaScript console, related to CORS, right? You'll know you're getting a CORS error if you open up the console to take a look at your response and take a look at your console logs and stuff, and you see a bunch of red errors that say, hey, you know, this request wasn't allowed because of CORS, right? The result of that issue basically is going to tell you in the console that, hey, you know, because of the fact that the server wasn't built for you to grab these resources, I can't give you the resources. So it'll say, you know, that request was blocked by the CORS policy. To fix that, right, which is literally one of the last things you have to do whenever you're working on the server side and getting your routes working and stuff, is on your server, you have to basically allow for, you basically have to allow CORS and enable it on your server. And that's why when we go back to the server side for a quick second, to do that, we had to import CORS into our server. That's what we're doing here. So we had to enable CORS by first bringing it into our project. Then we used it as middleware, right? And remember I said I'd get back to what middleware is, but middleware basically are little functions that you can call that are going to basically tell your Express app certain things before it sends all your routes to your client. So before it goes and, you know, does all the routes, it's the Express app knows a couple little pieces of information about itself, which just helps it work more efficiently, or helps you just do little things in between the process of before, you know, you finally call a particular route. With CORS particularly, right, this is the particular middleware we had to do, which was we imported CORS into our project, and then we had to basically initialize CORS. And CORS basically is going to ask, like, what are the origins or the external servers that we want to allow to get access to our to some of our routes, right? Here, I kind of use the origin star syntax, which basically allows all external origins to particularly get access to CORS enabled routes. Sometimes what you'll see are people, instead of origin star, they'll spell out the particular origin. So they'll say, hey, localhost colon 5173 or something, like something like this, oops. Right? So you can specify other particular URLs if you want it to be that specific, which is a bit better in security. But a lot of times you'll see people lazily just use the origin star or origin true syntax to basically enable CORS for any external server. For y'all, building is not a problem, but it's one of those things where once you start thinking about network security, you got to go back and reevaluate, like, how are you going to allow access? Which is why, if y'all recall last time, I tried to make a request to Google from our JavaScript and it was getting blocked by CORS, right? The reason why was because, Google's like, bro, who are you? they're like, hey, bro, you know what I'm saying? You smell too broke to make requests over here, buddy. You know what I'm saying? So, they was just playing me, you know what I'm saying? So long story short, right? CORS is what we need to do to enable particular origins to receive some data. So we had to add this middleware into our Express server. The last thing we had to do is we had to call CORS on our particular routes that we want to use it. So the way that CORS changes, if we look at route number 1 that I just highlighted, right? This route is a very simple route. It has a path and it has a handling function, right? This route, the second route that I just highlighted, it also has a path, but before we put our route handling function, we actually put a second piece of information in here, third piece of information here, excuse me, that is a middleware, right? So you can put middleware in your functions as you can pass middleware into your functions, into your routes, I should say, prior to your route handling functions. In this case, the middleware we passed was CORS, was like, hey, call CORS, which again, we imported it. We told the app that we were going to use it. And then we called CORS on a particular route for our server, right? So just by adding this, we essentially said that this route is going to be open for other origins to call, right? So that way we made it accessible for our client to say, okay, now you can get this data back from the server. So CORS enablement is like one of those like missing pieces a lot of times when folks are building their first servers, but it's important to know, it's just important to know that that's what that's doing, right? So all in all, with all of those pieces, with CORS enabled on the server, the route having CORS using CORS, our client making those fetch requests specifically to that route on the server, and us basically making sure we're handling the promise. That's all we got to do, right? And I say all we got to do, and y'all are like, bro, all we got to do? That's crazy. What? But that's all the crazy stuff you got to do, right? All crazy stuff aside, that's all the crazy stuff you got to do. So here's why this is important, and here's where you can go with this, right? Just with this information you just now learned from your boy Cam, talking about McDonald's and all this other random stuff, right? Just with all that information, now you can clearly pull information back from your own servers, right? So we're clearly pulling this information back from our own Express server, which is dope. 2 is now you can use other APIs in your code, right? Because other APIs work the same way. Instead of you reaching out to localhost 3000, let's say you were reaching out to Stripe and you want to get some data from Stripe. Okay, well, you replace this link with the link from Stripe. Or, hey, I'm building an app and I want to get data from Spotify. Same thing. I switch this link to, say, Spotify or whatever the Spotify API route is, right? all API routes are servers that are exposed to client traffic, allowing for you to get, post, and delete whatever data from those servers using a particular URL. Sometimes, though, those URLs require you to pass certain other information into them. And in those cases, when you're passing certain other information, you have to use, you can't just use simple GET requests in order to do that. You're going to need like a little bit more sophisticated requests, right? And we talked about some of those sophisticated requests a couple sessions ago when we were just deep diving into the server side part, and we said, hey, there's GET requests and then there's post requests, right? And give me a thumbs up if y'all remember when we talked about post requests. Hopefully some of y'all, hopefully somebody remember post requests. Yeah, you know what I'm saying? We talk about post requests, exactly, right? And post requests, like I talked about, are and I'll pull up Postman just to show us this, right? Post requests are essentially requests that you can pass information to inside of the request. That's how they're structured. Like a post request typically will say, hey, I'm going to make a post request to a particular route, and I'm going to pass some data into that request. I think I had a route prior that was like profile or something like this. I don't know if it's still gonna work. Okay, it worked. So this route profile, right, I had on the server running earlier. And that route was basically what it was doing was it was waiting for a post request. And the post request was gonna say, hey, I'm gonna pass some data into the request, and I want you to just print it out if you get it. So here, clearly it got it, right? But the most important part of the post request is, hey, I specify where I'm making the request, but I also am going to pass some data into the request and send the request finally, right? The way you send the data in a post request is pretty much the most important part. So here is where I give y'all something wonderful, because I still use this, especially when I'm working on very complex API routes and stuff, and they require a lot of different pieces of information, etc. Sometimes I'll use Postman, which is just the app to browse these network requests and test them. And I'll test it here, right? And try my best to like kind of get it working here. So let's say I'm working with the Spotify API, because I just brought that up. RIP all the people that got laid off from Spotify, by the way. But you know what I'm saying? Okay, let's say I'm using the Apple Music API. Oh, wait, maybe they laid off people at Apple. Okay, well, let's say I'm using the Music API and it didn't lay off nobody, right? I could go to that particular website's API and say, all right, boom. Like they might say, hey, you got a post request to make and you got to do this, this, and this to get the data back. All right, cool. So how I would work is typically I'd grab that API URL and I'd pull it into Postman to make sure that I can pass whatever information they need from me. Sometimes they need things like an API key or ID information, right? And they'll tell you stuff like, hey, you need to pass blah 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 in the body of that request, or hey, in the headers of your request you need to add a header for something. So what Postman lets you do is clearly you can add headers, add body, add params, whatever you need into a particular route, and then you can test it. So I like using Postman because I can test my network requests very easily in one place. No, they didn't pay me to say this. You know what I'm saying? I'm just telling y'all this is free game. But my favorite part of Postman, once you're doing all this and you're like, okay, boom, I got to bring this into my actual project, is I like using the code button here on the side. Give me a thumbs up if y'all can see this little pop-up that popped up here. I can't tell if it shares the whole screen or if y'all can't see it. Okay, good. Folks can see it. All right, so this little pop-up is lit because it will give you a bunch of code snippets for performing those network requests in different languages and with different libraries, right? So fetch, like I said, is the JavaScript default. That's the one everybody gonna use. But what's cool about this is you can see, hey, Postman is clearly giving me some help thinking about how I'd structure a more complicated API call or network request call. In this case, right, it's basically helping me make sure that I'm sending data through a post request to a particular route using fetch, right? And I just wanted to highlight some of the differences here between the regular fetch that we called and then the fetch that we're seeing here. In this case, right, the fetch request that we're used to was just very simple. It's just kind of like something like this, just by itself. But in this case, what we're seeing is a little bit more complicated stuff. But I just wanted to take a quick second to break down what this is doing. And hopefully then you can start adding other complex fetch requests to your code yourself. So I'll actually, I won't actually copy it over, but I think I can type in here. Yeah, I could type in here. So that's fine. I'll do it in here. So what this fetch request is doing is interesting. Let's start at the bottom because it'll help us make a lot more sense of it. So this fetch request is performing a fetch request to this particular path on the server, right? So it's saying, hey, I want to make a request to localhost 3000/profile, right? Okay, that's fine. We're used to that. Then it's passing in a object called request options to the fetch. So the fetch function can take both a path, just a general path, or it could take a path and some options for your request. Now, the options for the request, you could define all of them in line, right? Like I could take this and then, instead of request options here, I just pass it like this, right? But again, that sometimes makes things a little harder to read. In this case, maybe it doesn't too much, but the idea is instead of passing it directly into the function like this, they just use the variable to hold it. They just use the variable to hold it. Oh, now I can't delete it. So I got to type it back out. So request options, right? So what request options is doing is the most important part. Here is where they're specifying, hey, I'm going to use a particular HTTP method, post. If I had any headers that I wanted to specify, I could pass them into the request here. If I had a body of data that I wanted to pass, I could pass that body of data into the request as well, like so. The redirect follow is just ensuring that if the server responds with a redirect, it will also send back that response for me to in the request too. Basically, though, what I want to point out is what we see above this is the data, right? So here is like where, like, let's say the server is telling me I need to pass an object of data into the server. Well, here you can see, okay, cool. So I would define the data and I can use this JSON.stringify function to essentially turn this into a JSON string. The reason that's important is because we can't send directly through the network request objects. We have to send a string of information. And even if that string contains JSON, that's why JSON is very popularly used, because it's easy to turn it into a string and easy to pass it as a file, easy to then turn it into objects in JavaScript and run them in your application. But when we're sending response, or when we're sending requests, post requests, we're typically going to create a JSON and turn it into a string. We're going to use whatever data we want. So in this case, here's a bit of user data. And we're going to turn it into a JSON string, just using these two functions. But we're going to pass that data into our request options as a part of our fetch request, right? Same thing with the headers. The header that they did added up here, just for good measure, making sure that our server knows that the type of data we're sending is going to be of type application JSON. The reason this is important is because if you recall, when we send data, right, when I'm sending this data in the body of my request, the server doesn't necessarily know, hey, this request data is in JSON format. It doesn't know that unless I tell it through the headers of the request, hey, this is data of type JSON. There's a couple other types of data that you can send in the request. You could send JSON, you could send text, you could send JSON, text, XML, a bunch of other stuff, right? Form data. So here we're just specifying, hey, I'm sending you JSON so that the server knows to listen for JSON data and parse it appropriately. And that's all that's going on here, fam. The thing that might be throwing you off is, as you can see, even with Postman, they're still using the .then syntax here, right? So again, part of the reason why here is because this isn't in a function, right? But if I change this code by just adding, let handle requests, or like, let's say, let make post requests, right? And I make this a function. Well, if I wrap all of this in a function, what's cool is I get the opportunity to then say, okay, well, because this is a function, now I can use that async keyword. And instead of having to do all of these .thens down here, I can say, okay, cool. Well, let's take the first promise that's returning, which is the fetch. The fetch request is being made, and we're expecting once it finally finishes that we're going to have a response. So to change this to an async await syntax, I'd say let response get await that first line, that first fetch line here, right? So here I'm saying, okay, boom. So now I have the response as some data, right? Then I got the response.text being called. And again, remember we call response.json an R function, but response.text is another function that you can call on a response from fetch that also returns a promise. So if I want the text coming back from the server, like let's say I know that the server is responding with text. Well, then I might say, okay, well, let the text get await response dot text, right? And now I have that information ready to go. And so here now I can say console log result, and I can say console log text, right? And if there's an error, right? If there's an error, the dot catch is interesting, right? Because with the dot catch, it works very well when you're chaining, but you might be wondering, well, how do I catch errors if I don't do the dot catch syntax? And the answer, my friends, is using what we call a try catch block. So essentially, I'll wrap this in a try, and I'll create a catch that will catch any errors inside of itself, right? So if I catch any, so the try basically will say, hey, execute all of the code that is up here. And if any of these promises resolve with an error, we're going to catch the error. And then here's where I can say console log our error. So at the top, and let me just move this. Now that I did this, let me just move this. I was going to put this in a JavaScript file so it's easier to see. So let me just move this over here and create a new file for us. And so you can see it a little bit better. But here's the idea, right? We have this function that's making an async request. Because of that, we don't have to use the .thens .catch syntax. We could just use the try catch and async await syntax to make this a little bit easier for us to deal with, right? So both of these things are doing the same thing, the thing in the comment and the thing that's now underneath the comment. So this is how I would structure a post request from my client side, right? So currently in my client side, I have just a regular GET request being made. And if I want to be consistent, I'd also wrap this in a try catch block so that I get any errors that might come back in the networking request, right? And just would add here, right? Console log error, right? So this would be like a good networking request. Is like, okay, boom, try catch block. Inside of that try catch block, I'm doing my async methods and stuff, and I'm console logging if I get them, if something bad happens, right? And this is where fetch is cool because, okay, boom, I could just use this, get a GET request, everything works out the best way. But if I had to make a post request, I could do the same thing, right? Create a function for the post request. The difference between a post request and a GET request is typically with post requests, we're going to actually pass data into the server. Typically that data in a lot of cases is passed in the body of a post request, but there's also, depending on your server, depending on how you set it up, you might have to you might have to send data in a header, or you might have to send data as a part of a parameter into your particular route, right? But for the most part, like I said, is very standard that you'll see, hey, we pass data in the request body. To do that, I can define some data and create a JSON string out of it and send it into my body, right? I could, if I know that I'm sending data to a server, I will want to tell the server, hey, here's the type of data that it's going to be in, what format, so that when the server gets it, it knows how to parse that information. And with that information sent in the request and whatnot, right, the server can process it correctly and get that information handled properly, right? So if I were to change this, the one last thing, I'm so sorry, I can't believe I forgot to talk about this, but where are we calling this function, right? So fetch data, we talked about literally everything that's going on with this function, how it works, right? The last thing we had to talk about was where does it get called, which is when the component in our client side, and this is very specific to React, right? But when our client side is trying to call network requests, right? It typically happens before a component is being rendered, or we typically want it to happen before a component is being rendered, or we want it to happen, before things like that, the fave links pop up. So right now, right, we're fetching data in the link container, and that is gonna change the state and stuff. But we have to run this function somewhere. So what we did was we used another React hook that is very important to remember when you're using your client-side applications, especially in React, that you have to call these network requests in particular moments of your component's lifecycle. In our case, we're saying, hey, when our link container finally gets ready to go, it's loaded, right? We're gonna call fetch data, and that's what this use effect hook does. The use effect hook is essentially just a hook that lets you run a function based on data changing, certain data changing. If we wanted to change it based on like our state changing, we could say, hey, run this hook when the fave links array changes, right? Well, that might be good if, like, for instance, let's say you wanted to add some logic to your server and your client side based on what you've seen today. And you're like, hey, whenever I submit data, I'd love to update that data in the server, like, and send back and, post some data to the server. Well, cool. Well, I might have, like, if I had this function, this make post request function inside of my code, right? Which I guess I could just copy it over now. So if I have this little make post request function inside here, we already talked about it, so I'm just gonna minimize it, right? Maybe I'm saying, hey, if the fave links array changes based on the form being submitted, instead of fetch data, I could say, hey, make post requests or something. And then of course, I'd have to change this function to be a function that, this is if I had a route. Let's say I had a route that, like, post links or something. And this link was listening for my fave links that were changed. And then I could say, hey, take my fave links and turn those into JSON, right? Right? Take this little fave links object that I have in my state and turn it into JSON, and then send it to my post links thing, right? Well, the use effect hook would be helpful in anytime this fave links got changed, this function will be called. But when I have the use effect empty like this, right? It will run in the instant, the first time the component pretty much loads. And so that's how we call this function, right? And this syntax of just using a use effect with a function that is an async function is the recommended way of calling network request in a React component when you're trying to load it into a React component. You would basically create your like fetch data is a function that I defined externally with an async keyword. And so because I have this function externally, I could just say in the use effect, hey, call that function, right? That's kind of the recommended way to use effects, to say, hey, when this component loads, let's do this network request. And in that function, right, I can then do stuff like say, hey, I could do stuff like save that into state, right? For instance, like save the state of the fave links to include that data or whatnot. And yeah, that's kind of how that works. Now, let's think. As a recap, because I think it's real important to do that. Client side and server side stuff are very important on their own, right? If you're at the level where you can build a little React application, you feel confident that you can build your components out and, manipulate them using props and state and, these little event handlers or whatever from like on clicks and stuff like that, then great. You're in a great place on the front end and on the client side. On the back end side, right? What we need to do is we really like being able to create servers to start running specific routes. And what you are starting in this process is being able to create your own APIs that are servers that you can then say, hey, other applications can go to my server and get this information, right? In our case, we just did one simple example route, which was a route to get some data that we defined here, right? To get to what I was showing just toward the end, right? Imagine if I had a route for like posting data and I said, hey, app.post, if the client reaches out to, favelink / update or something, right? Then in here, I could define a route where if the client reached out to that particular route, right? We could get the fave links. We could get the fave links off of the request body, maybe, right? So like if they pass the fave links into us, we could do something, get the fave links body, and then like, save this somewhere like a database or something, right? So that's what I meant when I said, oh, we could have like a post route that maybe in our app, as things are changing, we send some data here. But I don't have that route yet. But maybe you're interested in working on this. And hint, you might have to soon. But either way, right? Our server defines the routes for our client to reach out to. If I want this route, much like I wanted this route to be able to be reached by the client, I gotta use middleware like CORS in order to open up that traffic so that this route can get and send information as well, right? Now the server side is fairly simple, right? We created the Express app. We use this middleware in order to, particularly this middleware to initialize CORS. I'll talk about these other ones in a second. But using CORS was used for helping us allow for us to send data down to our clients. The client is really realistically going to be responsible for saying, hey, I want to make some network requests, right? How you make the network request and where you make the network request are two different things. How you make the network request is like I told you, we're just going to make a fetch request and wait the promises out, get the data from the promises, and then do whatever we want to do. And, the best syntax is like this, like try catch syntax, so that you can try doing all that stuff. And if anything goes wrong, you can catch any errors. That's simply put all you have to do from the client side's perspective. But again, in a React application, because this isn't just a regular JavaScript app, right? We have components. Well, we gotta call these types of functions in specific moments when our components are being loaded, or particular moments when the page is finished rendering or whatnot. To do that, we have to use the use effect hook in React in order to call functions in particular life cycles of our components journey. So that's why we had to use this use effect in our React code in order to fetch the data finally, which was that function that we defined above here to get the data back from our server. Adding CORS on the server is what finally allowed this to work. And if we didn't add cores and we tried to do all of this, we would not see anything visually on the app in the React app, but we would get some errors in the console. So remember, when you're troubleshooting network requests, and for this part, let me just switch back over to the actual local host, right? You're not going to get any errors on the network side showing up visually here. If you want to troubleshoot any errors on like a networking thing, it's best to like check your inspector in the console, because the console will show you if you're getting any particular errors. Yeah, so I'm not getting any particular errors right now, but before I was getting a ton. If you want to see those errors, go back to the end of the last video. You'll see me start sweating as I was getting them. But in this case, we're not getting any because of the fact that we call cores on those particular routes. And that's what's making all of that work the way that it's working. So that's really that on the core side. On the server side, how it's working, sending data from the server into the to the client. Now, I want to point out one last thing as it relates to the server side and client side, and how we've structured this server, right? And it goes back to all this middleware that we're using here. So we talked about this middleware for cores, which is the app.use. This is the only one you need if you're just trying to get cores to work. You just need this this cores middleware here. Now, but we have like 3 other ones that are here as well. So let's just explain what these ones are, and I'll actually leave this for enabling cores. So this first one, app.use express.json. Basically, this middleware is basically saying, hey, if we ever are seeing a route, request come in, and the request is if we're seeing a request come in and the request is using application/JSON data, then we can parse it, because we know that our application in Express is using Express JSON to parse any application JSON data that it sees. So this is just a helpful one to add to your Express servers. If, for instance, hey, like remember in that client side sample function that I had, in this client side function, right? I was saying, hey, we might send JSON to a server, and we got to tell that server, hey, I'm sending it of content type application JSON. Well, this is exactly how I would want to structure this on the client side, so that the server knows, hey, this is JSON data. But on the server side, this middleware here is what allows for Express to basically say, hey, if I see any application/JSON type requests or data in those requests, then I can parse that, right? As you can see this, it says it returns middleware that only parses JSON and only looks at requests where the content type header matches application/JSON. So that's what this one is, and that's why I had it in here, was in case I wrote some post requests where it was expecting application/JSON data. URL encoded is a similar one, but this is for application data where you might be sending a body of data that is sent through a URL encoded content type. So this one is for application/JSON type data. This one was more for URLs and data coming back from forms. Sometimes get sent in this way. Technically, I don't really have any thing on my client side sending data this way. So this isn't necessarily important. But these two middleware pieces are sometimes just helpful, especially if you're going to have data coming in your request body, so that you can see that data and deal with that data the right way. So remember here in this like Favelinks update, if I were to say rec.body and I didn't have a particular one of those things parsing the data the right way, I'd get like that the rec.body was undefined. But with having those 2 pieces of middleware, right? If this rec.body is of content type application.json, this will get parsed correctly as JSON. If this was of type URL encoded, this will still be parsed the right way, right? So that's why those 2 pieces of middleware are here, and hopefully that makes a little bit more sense. The last middleware that we have is this app.use express.static, and it's using this this folder called dist. So this was just an experiment that I was playing with, but what the express.static function does is it basically converts files or folders into static assets that would allow for them to be sent over the server. So if somebody requested any information that was inside of this particular folder, they would be able to receive it as a request, right? This is step one in being able to have data that I can get from my server just by just kind of statically. And what I mean by statically is like I can say, hey, localhost 3000. Basically, I could say I want some files from that dist folder, and I would be able to pull it back in the what's it called? I would be able to pull it back inside of my request and send the data. Basically, I'd be able to send the data. I'm sorry, y'all. I was getting late. my brain tweaking. But and I'm sure y'all's are too. So we're about to wrap up right now. But what you see in this server side is right. Like I'm first making this folder, this distribution folder, static. Now I did this in order to do one really important thing that is always something that folks care to know. And it helps us answer that question we had before, which is, remember how when we ran the React server, it was running on localhost 5173, right? And it was returning our React application. Well, how do we do that on our own servers? Well, the cool thing is that we can do that very easily using what we know about Express. So all we would have to do, realistically, if I want this to run on port 5173, is change this port to 5173, right? I don't want to do that right now because I have something running on port 5173, but that's as simple as changing this port number here. Now, when we launch port 5173, right, it just kind of launches our React application. So what it's doing is at the root route of that localhost 5173, it is sending us back our HTML that is coming from the React application. And so what I did in this particular route is a little bit of that. So what I did was say, hey, if you go to my server and you go to the root route, right, I'm going to send you a file where the file is basically pointing to the index.html file that is located inside of that distribution folder. So in order to let this function work and send this file in this way, I had to first make sure that that distribution folder was a static asset in my code base. So that's what this particular piece of middleware was doing, is making sure that that folder, the distribution folder, was static, and then it's able to then send the file, that HTML file, down in my request, which makes it so that if I were to go, and I'll just switch over real last thing for y'all real quick, right? If I were to go back to my browser, right? So remember, here's the server, it's running, here's that favlink/data route, right? But if I go to just the regular root route of my server now, right, I actually see my React application. And the reason why is because what that distribution folder really is, my Favlinks project built out, right? And with Vite, whenever you have any React project, most React builders have this feature in them. You just have to look and see what code you have to call to do it. In this case, with Vite, right, our React project comes built with a build script. And the build script, basically, if you ever ran npm run build on this Vite project, what it will do for you is create a distribution folder of all of your bundled React code. This distribution folder is what, when we finally want to host our React code on a server, this is the assets and these are the files that we typically will put up there. So all I did was ran that command to build my React project as that folder. I got that folder here. And just for the sake of testing, I copied that folder over to my server side project, right? And so I brought it into my server as a folder, and then I was able to say stuff like, okay, let's make this a static asset. And then if I want to make a route that returns that React file, or that index file that's using React, I can send that file just like this. So that, my friends, is a pretty hefty and healthy intro to how can we connect our client side and server side, right? Hopefully it makes more sense. If it does, please give me some love. You know what I'm saying? It's hard talking about all these things and not knowing if folks get it. But I appreciate your time and your attention. We talked all about how to create these routes, how to connect to these routes on our client. And just now, as a little bonus, we talked about how can I send back my React project or host my React project on my default route as well. So tune in next time. We're going to keep talking about this server side stuff, talk about databases and all that stuff, which is just the next step of adding to our server. But with all the information that you know now, you should be able to create your own full stack applications, connect to them on a client side and server side tip, and also bring in some external APIs as other routes that you might want to connect to in your server, or other routes you might want to connect to on your client side. So with that, fam, I'll be signing off. Appreciate y'all. Stick around if you have some questions. Otherwise, I will see y'all.